Okay. My name is Pearl Cao. I'm the director for power delivery at NXP, focusing on fast charging and USB-C protection power switch products. Today, I'll be presenting on Safe Power for a Greener Future, which highlights the safety and efficiency aspects of the power technologies. I'll first introduce a high-level overview of emerging trends in different applications for power systems. Then I'll discuss the charging technologies from the wall to the battery, including AC/DC conversion, wireless charging, and wired charging with different battery charging topologies. We'll also highlight the application opportunities associated with these technologies and also NXP's product offerings. One of the focus areas for NXP is advanced power systems to enable power system solutions for all verticals, including automotive, industrial IoT, and mobile. The vehicles today are essentially computers on wheels that will become servers on wheels in the future. With all the built-in sensors, cameras, and internal networks, they will be able to detect everything that's happening on the road, including cars, pedestrians, and street signs. The cars will be permanently connected to their surroundings. This is a revolution for the entire automotive industry. And this cannot happen without the innovation of the electronics or software. The rising compute performance is driving higher currents and higher efficiency power components. Another trend is the processors are moving to submicron technology, such as 5 nanometer, 7 nanometer. These processors require low voltage power supplies, such as 1.2 volt or even 0.7 volt. The process also requires tighter tolerance with aging taken into consideration. 10% accuracy at 5 volt is a lot easier to meet than 10% accuracy at 1 volt. And even 10% accuracy may not be enough here. So high precision power supplies are required with extended monitoring. Another big trend is the vehicle electrification. The power system is being re-architected to support these 400 volt, 800 volt, and even higher voltage EV. This presents opportunities for higher efficiency car battery charging and battery management. Scalable 12 volt, 48 volt solutions are needed. Innovations of AC/DC, DC/DC converters are needed, and functional safety has become a critical element to be considered on the system designs. It's not just about how to react to the failure, but rather how to predict the failure and manage the potential failure before it happens. With these new requirements coming up, we are seeing more and more electronics or chips going into the vehicles. NXP is known to be a leader in automotive processors. We have also been providing a system solution with PMICs to power these processors. And our PMICs are also recognized as a leader in functional safety, especially on the SLD level for the system basis chip. Now on the mobile, industrial, and IoT side, one major trend is the adoption of USB-C power delivery. USB-C was first seen on mobile phones and notebook computing applications. Now it has been expanding into more industrial and automotive applications. Last year, the specification increased the maximum power level from 100 watt to 240 watt. The European Union is working to standardize the USB-C connector for all electronic devices to increase the consumer convenience and reduce the e-waste. These activities are expediting the broad market adoption of USB-C. With the increased power demand, more opportunities have come up for fast charging and a high voltage, high power protection. At the same time, the market is demanding a smaller solution size, such as the thinner TV and the smaller computers. This drives the power density to increase. And again, is a great way to increase the switching frequency and shrink the solution size, as Dan mentioned just now. Last but not least, the IoT space is seeing tremendous growth in healthcare, smart home, factory automation, and many other applications. The wearables, like the smartwatch you have, is not only good for fitness tracking, it can also be used in healthcare for remote monitoring of COVID symptoms. It's also capable of helping to prevent COVID by maintaining social distancing and contact tracing. Many of these applications are small battery, space-limited applications. They demand long battery life with low power consumption. Innovation on fuel gauging and energy harvesting are needed. The Industry 4.0 and 5G adoption are giving further boost to this IoT space as well. While NXP innovates to address all these market trends, we also have a guiding principle to ensure sustainability. The green chip products are used extensively in power supplies and fast charging adapters. They can be tailored to minimize energy consumption in the end products they are embedded in. Now on this note, I'll move to the charging technologies from the wall to the battery. The charging system usually starts from the wall plug with AC/DC adapter. Then the end product, such as the smartphone, can be powered wirelessly or through a wire. A lot of the phones are using Type-C connector now. And inside the phone, there is at least one charger used to provide the charging profile required by the battery. So I will first start with the AC/DC conversion. If you look around your home or your office, you probably find multiple AC/DC adapters. They are used everywhere, from consumer electronics, computing to server and telecom infrastructures. As we discussed just now, the market is demanding higher power level and a higher efficiency. At the same time, functional safety is not only critical for automotive, but also a key consideration for industrial applications. The power supplies need to have accurate monitoring and protection on voltage, current, power, and temperature. For a resonant converter, they also need to make sure the system operates in the inductive switching region instead of the capacitive switching region to prevent the FETs from getting damaged. This is what we call the capacitive mode regulation. The brown-in, brown-out protection is another safety feature to ensure the converter only operates when the input voltage is not too low. When the adapter gets unplugged from the wall, the input voltage drops. If the load demands a high power at low input voltage, the current can be very high. This high current can heat up the electronic components and turn them brown. This is why we need a brown-in, brown-out protection. Here are the high-level block diagrams of two popular AC/DC architectures. Both architectures have a primary side and a secondary side. Primary side, secondary side with a transformer in between. The flyback converter is typically used in less than 75 watt low power applications. The way how it transfers energy is that you can picture it as taking a bucket of water, pour it into a storage tank first, and then pour it into the secondary side. Whereas the resonant converter on the other side is constantly transferring that water from the primary side to the secondary side without a storage. So it is more efficient, and it's usually a good choice for high power levels. The resonant converter requires 2 times of FETs and diodes compared to the flyback architecture, so that they are more expensive at the same power level or low power level. However, they provide a lot of benefits at a higher power level. NXP is a leader in the resonant power side, and here are some part numbers in case you need. These NXP resonant power products are not only very efficient, they also have proven quality track record, and they are ISO certified. Now I will move to the wireless charging portion, the wireless charging transmitter especially. Wireless charging, looking at its name, means charging without a wire. Magnetic field is a popular method for this non-conductive power transfer. Wireless charging provides convenience to the consumers. Imagine you are driving in the dark and you need to search for a charging cable to charge your phone, where you are supposed to look in the front and keep your hands on the steering wheels. We are seeing really good adoption for wireless charging inside vehicles. Wireless charging without the connectors and the pogo pins can enable new designs and form factors for the vendors for differentiation. Some applications, such as medical surgical equipment, would also appreciate a hermetically sealed design for the ease of cleaning. In the wireless power system, there is a power receiver and a power transmitter. The receiver is usually inside the device that needs to be charged or powered. It can be a phone, it can be a tablet, it can be a smartwatch. The transmitter can be inside a car, can be installed on a table, or just a standalone charging pad that you can place it anywhere. Here, I want to mention two wireless charging technologies. NFC is a very popular technology used widely in our life for contactless payments and data transfers. It's a short-range technology operating at 13.56 megahertz. It was actually co-invented by NXP and Sony in 2002. The NFC Forum released a wireless charging standard in 2020. The Universal Stylus Initiative, USI, released the NFC wireless charging specification addendum in 2021. This means all the stylus has to use NFC technology for wireless charging. This technology is great for low power level, such as 1 watt to 3 watt. On the other hand, the Wireless Power Consortium, also known as QI, is a great choice for slightly higher power level charging. The operating frequency is around a few hundred kilohertz. This is the most established wireless charging standard in the market today. Because of the obvious advantages of wireless charging, there are many applications looking to adopt it. The most popular solution is still for the smartphone charging, especially in the car for the wireless power transmitter side. Here is a picture showing you how the black box transmitter module actually look like inside. The 3 coils are here to increase the spatial freedom, so you don't need to perfectly align your phone with a single transmitter coil in the dark while you're driving. Wireless charging can be a complicated system with transmitter, receiver, and coils involved. It's also an ecosystem with certification and regulation involved. NXP is a leader in the automotive wireless power transmitter solution, and we can provide the full system support here. Now I will move to the wired charging. When we talk about wired charging, we cannot ignore the charging wires. USB Type-C is the most popular connector for smartphones and many other applications now. So I'll give a little bit background introduction about the USB-C power delivery. After multiple specifications, USB 4 now supports up to 40 gigabit per second data transfer rate with 2 channels. USB PD extended power range enables up to 240 watt power transfer. The USB-C connector is a small reversible connector, very user-friendly. With all these benefits, the USB-C connector is seen to be the de facto connector for the future, even beyond notebook and smartphones. Before I talk about the smartphone charging in my following slides, I want to highlight this programmable power supply specification introduced during the USB 3.0. This specification allows the sync side to request very fine voltage and current steps from the source side. In a smartphone application, the sync usually refers to the smartphone and the source will refer to the AC/DC adapter. The PPS is a major milestone that enabled fast charging with switch capacitor technology. This switch capacitor technology is also known as divide by 2 charge pump technology. It significantly increased the power conversion efficiency and reduced the power loss. What does power loss translate to here? It is the thermal dissipation, the heat. This technology is revolutionary for providing a better user experience with cooler and faster charging. I'll discuss the switch capacitor charger a little bit more in the following slides. Another industry trend I want to highlight here is the EU standardizing USB-C for all electronic devices to increase consumer convenience and reduce the e-waste. What does this mean to us? The the news will expedite the USB-C global broad market adoption beyond notebook and computing. The USB PDE-PR extended power range will also drive new IC development for higher voltage and higher power levels. So this is opening up a great opportunity for the semiconductor industry, for our customers, for our end users. Now I'll move to different battery charging topologies. Linear charger is like an LDO with more regulation loops. It's simple, small, and low cost. No EMI concerns since there's no inductive switching. The disadvantage is the low efficiency. It's basically adding a resistive load in the system. So linear charger is usually used in small batteries, space-limited applications with low charging current. When higher charge current and a faster charging is needed, switching charger is a popular choice. It also has a buck boost and buck boost topologies to provide lower or higher output voltage than input voltage. Since it is using inductor switching, it could require more layout considerations due to the switching noise. Switch cap charger is a relatively new topology in terms of market adoption. This topology does not use any inductor. It only uses capacitors to realize the high efficiency power conversion. While it is more efficient than traditional inductive switching charger, one disadvantage is that it has a fixed input to output ratio, which means it can be 2:1, 3:1, 4:1, but the output voltage cannot be just any voltage. The programmable power supply PPS specification we mentioned just now really helped this topology's adoption. 7 years ago, 15 watt is considered fast charging for smartphone. Today, you see a lot of 30 watt, 50 watt, and even 100 watt mentioned by Dan just now for the smartphones. This will not be possible without a switch cap charger here. Now I want to talk a little bit more about why it is important to have high efficiency charging for the phone. The smartphone is a very space limited application. To make sure the charging temperature doesn't burn people's hand and the battery doesn't explode. Maybe I'm exaggerating a little bit here. The power loss budget for smartphone charger can be only about 1 watt. When charging at 50 watt, a traditional inductive switching charger can cause 4 times power loss as a switch cap charger. This is why smartphone fast charging requires switch cap chargers. With fast charging becoming more and more of a standard feature for smartphone, we see higher demand on switch cap chargers. One thing I do want to mention is since the switch cap charger does not have a regulation for any voltage, an inductive switching charger is usually still used in parallel with the switch cap charger for the smartphone charging to handle the pre-charge and the termination phase for the charging profile. I want to mention NXP is not only a technology leader in these few areas we discussed today. NXP is also a leader in functional safety. NXP has a Safe Assure program that connects experts with designers to share deep automotive and appliance safety knowledge, the vast product development resources, and also strategic alliances with key industry partners. All these are having the same end goal to help you produce fully certified products and keep customers safe and satisfied. With that, I conclude my presentation today. Thank you very much again.
Thank you very much, Carol. That's really excellent presentation. So we do see some questions up from there, from chat box. So interesting question to me too, because I was in this field before for USB-C PD. A question about they want to use audio power from USB-C PD. I honestly don't have much idea. I don't know if this is relevant. The audio power from USB-C PD?
Yeah, that's a good question. I think Honestly, I don't have a lot of expertise on the audio power side for the USB PD. I've been mostly working on the power analog component side for the fast charging, for the protection. So I think maybe I can take this offline and then connect this person
Sure.
with our experts in this space, and then we can
Sure.
get back to you.
Yeah. Yeah, you can see that from our chat box too. And another question is why NFC wireless charging max power level is very low? I think this it can be I better let you address that. It's only 1 watt to 3 watt NFC power.
Yeah, actually,
wireless charging.
Yeah,
okay.
most of the applications we see today are actually even less than 1 watt for the stylus pen. You can imagine, in the stylus pen, the NFC coil is very, very small.
Right.
So with the limitation of the coil and also the transfer efficiency, the frequency 13.56 megahertz, and also the need of that end product, the 1 watt, no more than 3 watt is typically what we have seen as the sweet spot for NFC charging. And the standard today is only up to 1 watt.
I see. Yes, thank you, Pearl. I have one more question about this. Between, we see you're presented both wired and wireless charging. So between the two big area, how's the roughly market share to go to each side, like the USB-C PD and the wireless power? Because honestly, back to a few years ago, I was working on the PD controller market. And that moment, the market really, all the market reports said that will be really booming market for USB PD. But now we do see the wireless power actually also growing very rapidly. And I see NXP really doing a very good job. You do both. So no matter which one is, go better path, you will win both. So, but I'm still wondering, between the two, how do you see that? What's your perspective between the two kind of charging solutions?
Yeah, I still think the wired charging is taking a bigger adoption than the wireless charging. So by the way, they could coexist. A phone could have wireless charging, could also have a wired charging. So you see a lot of the phones today, they have a wireless charging feature highlighted, while they also have the USB-C charging for the phone. So it's more about what is the adoption rate or attach rate for the wireless charging when you are having already a wired charging. I've seen the adoption rate is increasing for the wireless charging. And thinking about application use case, I think this is where NXP was investing in, was really the automotive wireless power transmitter, not necessarily the receiver inside the phone or inside the notebook, tablets. Yeah. And then for the USB-C wired charging side, there's definitely tremendous growth, especially with the power level getting higher and higher for the USB-C charging. And also the EU standardizing the USB-C as a common connector for electronics devices. This is impacting the global semiconductor industry and also the manufacturers right away. So we're already seeing that trend. And for the growth for I would say that there is going to be growth for both wireless charging and also wired charging. And we are, for my business, I'm more investing in the USB-C portion. Yeah.
I see. Oh, thank you, Pearl. Yeah, that's very, very in depth. One more question I have is, what do you see the majority application to drive the PD a power delivery, and USB power delivery? Like in terms of watt and the wattage range, it's pretty broad, and even now I see from your presentation it can extend to 48 volt. That's really a lot of power now.
Yeah.
So yeah, I'm wondering moving forward, you see which kind of area of the power range would drive this grow even faster. I mean, a USB PD side.
Yeah. So USB PD today, the connector is mostly seen in the smartphone side and notebook computing side. So for smartphone, it started with 15 watt, 5 volt, 3 amps, and now it got to 30 watt, and it moved to 50 watt and 120 watt, even 200 watt is already there with some small portion of the products. And on the notebook side, most of the adapters has been more than less than 65 watt, even just about 45 watt. But one trend we are seeing in the notebook computing side is there are going to be more and more performance notebooks to replace some of the desktops. And the fast charging, just that whole nice user experience is also going to drive this adoption. And outside of the mobile phone notebook, there are also many other applications that could really benefit from the USB-C. For example, the power tools. Today, there are a lot of power tools with different adapters. With the EU standardizing this USB-C connector, the power tools can really take that inbox charger out and to reduce the cost for the vendor and also increase the user experience for the end customer. And power tools is very big in Europe. And another and another application even including the e-bikes, the e-scooters, e-bikes, the batteries could have 12 cells in series, could have 10 cells in series. So they could be powered or charged with a 48 volt input. And on there, if you think about your e-bike, you're not only charging the e-bike battery, you could also be taking the power from that e-bike battery to power your phone, to power your GPS while you're on the bike. So there are actually multiple USB-C connector opportunities, right, on a e-bike. So, right. So along the lines, there are also monitors. A lot. You look around your home, your office. There are a lot of portable electronics that could benefit from the USB-C, and some of them do require higher power. Like the displays are getting bigger, the TVs are requiring more power, and all of these. Just think about whatever you think you want to get rid of your AC/DC adapter, that black box. USB-C could be the solution.
Thank you, Perl. There's one last question we'll take from the chat box. I think people are very curious about the switch cap charger, about the the application environment. They wonder like very hot ambient temperature, and they just wonder if that can operate in. I guess they're more like curious about if that's the cap charger can be able to operate at the very high ambient temperature environment.
Yeah, so the temperature is actually more of a constraint to the battery itself rather than to the switch cap or inductive switching charger itself. The charger or the electronic components usually have a rating can be minus 40 degrees C to even 125 degrees C. But the battery itself, the technology today has the limitation. For example, in the smartphone charging, usually you don't want to exceed 85 degrees C. So it's really the battery, what is the temperature range the battery can tolerate. And there are many different battery types. In a smartphone, usually it's lithium ion type of battery, which has a tighter temperature range. Some of the phone charging don't even want to exceed 55 degrees C. Whereas there are nickel metal hydrate batteries that has a wider temperature range, and you see them being used in automotive and industrial applications. So depends on where the switch cap charger is used with what type of battery, that would decide the ambient temperature requirement.